Is our universe real? Or are we just characters in a cosmic computer game? For decades, this has been a mind-bending thought experiment. But what if it's more than that? What if we could find a machine running it all? Welcome to the Bizarre Bureau. Today, we're not just asking if we're in a simulation. We're asking, what is the reality engine that powers it? The simulation hypothesis, popularized by philosopher Nick Bostrom, suggests that what we perceive as reality is actually an incredibly advanced computer simulation. Think of it like a hyper-realistic video game. We, along with everything we see, touch, and feel, are just bits of code. Bostrom's argument is statistical. He proposed that any civilization advanced enough to create such an ancestor simulation would likely create billions of them. If that's the case, the odds are overwhelmingly that we are one of those simulated beings, not the original biological ones. It's a sobering thought, isn't it? The stars above might just be pixels on a cosmic screen, but this raises an even bigger question. A simulation needs a computer. A program needs hardware. So, what kind of machine could possibly run a simulation as vast and complex as our entire universe? This isn't your average gaming PC we're talking about. The sheer scale is almost unimaginable. Think about it. There are about 2 trillion galaxies in the observable universe, each with hundreds of billions of stars. Down at the quantum level, particles pop in and out of existence trillions of times a second. To simulate every single interaction, every star, every planet, every atom, from the Big Bang to the present moment, would require a level of computational power that dwarfs anything we can conceive of. Let's call this hypothetical supercomputer the reality engine. What would it look like? Some physicists, like Seth Lloyd from MIT, have tried to calculate its potential. He estimated that to simulate the universe since the Big Bang, you need a computer with about 10 to the power of 120 bits of memory. That's a 1 followed by 120 zeros. For comparison, all the computers on Earth combined right now hold a tiny fraction of that. So, the reality engine would have to be quite literally out of this world. One possibility is that the reality engine isn't a machine in a higher dimension, but that the universe is the computer. This is the it from bit idea, championed by physicist John Archibald Wheeler. He famously said, every particle, every field of force, even the space-time continuum itself, derives its function, its meaning, its very existence entirely. From the apparatus elicited answers to yes or no questions, binary choices, bits. In this view, reality is fundamentally information. The laws of physics are the algorithm. Particles are the data. Space-time is the processing structure. The universe computes its own evolution. So, the hardware is the universe itself. This neatly solves the problem of where to put such a massive computer. But if the universe is a computer, shouldn't we be able to see the pixels? The smallest possible units of space, time, and energy? This is exactly what some scientists are looking for. One idea is that space-time isn't smooth and continuous, but is instead made of discrete, indivisible units, like the pixels on a screen. These are called Planck lengths, the smallest possible measurement in physics. If we could build instruments sensitive enough, we might be able to detect this grayness of reality. It would be like zooming into a digital photo until you see the individual pixels. Finding this would be a monumental discovery, the first piece of hard evidence that our world is a digital construct. Another fascinating clue comes from the strange world of quantum mechanics. Particles that behave as if they're being watched. The observer effect suggests that a particle's properties, like its position, aren't fixed until they're measured. Before that, they exist in a cloud of probabilities. This sounds suspiciously like how a video game engine works. It doesn't render every detail of the game world all the time. It only renders what the player is looking at to save processing power. Could the universe be doing the same thing? Is reality only rendered when a conscious observer, like us, looks at it? This would be an incredibly efficient way for the reality engine to manage its resources. Let's also consider the speed of light. In our universe, nothing with mass can travel faster than light, It's the ultimate cosmic speed limit. In a computer simulation, this could be the equivalent of the processor's clock speed. Information simply can't be processed and transferred from one part of the simulation to another any faster than this fundamental limit. It's the refresh rate of the universe. When we look at the constraints of our reality, like the speed of light or the laws of thermodynamics, they start to look less like cosmic mysteries and more like system limitations imposed by the underlying hardware of the reality engine. So who or what would build such a thing? Are they scientists, artists, or just cosmic kids playing a game? We can call them the simulators. If their goal was scientific to study the emergence of life and consciousness, then the simulation would be designed to run without interference. They just press play and watch it unfold. If the purpose was entertainment, then perhaps our lives are part of a grand narrative for an audience in a higher reality. A bit unsettling, but it's a possibility. There's also a more abstract, almost spiritual idea. What if the simulator is the universe itself, trying to understand its own existence? This is a concept known as a self-simulating universe, a loop where consciousness arises to observe the cosmos, and the cosmos exists to give rise to consciousness. In this scenario, we aren't just characters in the simulation. We are the universe's way of becoming self-aware. We are the senses of the cosmos. Our thoughts, our discoveries, our art, it's all part of the universe's process of self-exploration. The reality engine isn't just running a program. It's on a journey of self-discovery, and we're along for the ride. Of course, the simulation hypothesis is, for now, just that, a hypothesis. Many scientists are highly skeptical. They argue that these so-called clues are just our attempts to explain a complex reality using metaphors we understand, like computers. We live in a digital age, so we see the universe as a computer. In the Industrial Revolution, people compared the universe to a giant clockwork machine. They argue that reality is just reality, weird and wonderful as it is, without needing a creator or a computer behind the scenes. But the debate is what makes this so exciting. It pushes the boundaries of physics, philosophy, and our own imagination. So, how could we ever prove it? One proposed test involves studying ultra-high energy cosmic rays. These are particles that travel across the universe at incredible speeds. If space-time is a digital grid, these particles shouldn't be able to travel equally well in all directions. There should be a slight preference, a subtle pattern in their distribution across the sky that reveals the underlying structure of the simulated grid. We don't have the technology to detect this yet, but we're getting closer. Imagine the day we find definitive proof, the day we find the code. What would that mean for humanity? Would it cause an existential crisis? Or would it be liberating, freeing us from the perceived weight of cosmic meaninglessness? Knowing that we are part of a larger design could give our lives a new, profound purpose. Maybe our goal is to be interesting, to learn, to create, to be the best possible characters we can be for whatever reason this simulation was created. Or maybe, just maybe, the ultimate goal is to figure out how to level up, to understand the rules of the simulation so well that we can learn to bend them. Perhaps even make contact with the simulators themselves. What do you think powers our universe? Is it a vast, unknowable natural phenomenon, or an elegant piece of code running on a cosmic supercomputer? Is the speed of light a law of nature, or a processor speed limit? Let me know your theories down in the comments. The truth might be stranger than any science fiction we could ever imagine. And here at the Bizarre Bureau, we'll keep digging for it. Thanks for joining us on this journey into the heart of reality itself. If you enjoyed this cosmic conundrum, be sure to hit that like button, subscribe to the Bizarre Bureau, and ring the notification bell so you don't miss our next exploration into the unknown. Until next time, stay curious.